Perfect. So basically the one step that we add in 8.6 is this. I currently am looking at this and it's intimidating because we have 3 variables, right? And that shouldn't scare us at first because what I'm looking at is we have an x-axis and a y-axis. We get that. The x-axis is our left and right. Right? Where's my pen? X-axis is left and right. The y-axis is up and down. And the z-axis adds a 3rd dimension. Okay? Basically, think about a point like either coming above or below your paper. It just adds a 3rd dimension. That's if you want to get all crazy into this, but it adds this like 3rd line that comes off your paper, and that's the z function. Okay? You may not care about this. You're guys going, oh my gosh, we're just doing this for the sake of doing it. This actually has some really cool applications. One of the neatest applications for me when I think about it, I like video games. And video games, they do programming, and they program 3D. They actually go through and they use this math on a much larger scale, and they create 3-dimensional objects. Okay? I've actually had classes where I had to do that, where I had to program 3D things on a 2D screen. Okay? This is the math that I was using to do that. Okay? On a much larger scale. Okay? And you're like, okay, well that's kind of cool. Maybe I could do that. One of the things that I know, and I'll get off video games for those of you who don't like them, but I'm going to just do this real quick. Like, this is where the money is made too. Like, you talk about when, like, all the, what is it, like 60 or 70% of the games that are made right now are using the Unreal Engine. What is that? Well, these one guys were really smart, and they went through and they created an engine that used all this three-dimensional math, created all this world of physics, and then once they're done with that, other companies go, I don't want to make all that. That takes a lot of time. So they pay them money to use their engine. And so these one group that's really smart, they keep making money on every game that's made that uses their engine. That's where the money is made. Okay? So this has some applications. If you don't like games, maybe you like health. I think 3D printers are cool. This is the math that they use to do 3D printers. I said health, though. You're like, how's that health? One of the things I've heard with this, when they're talking about stem cells, they're actually taking like 3D printing technology, and they're going to be trying to develop organs with 3D printers. This is what they're using. They're able to make formulas in 3rd dimension where it's going to be able to print out, you know, I need a new heart. Prints out your heart. I think that's pretty cool. Okay? We do this already with prosthetics, with limbs, with people. They size them to you. This is the math behind that. We're not going that deep. Okay? It has business applications. If I ever purchase something that has more than second, 2 things, we could add a 3rd variable, a 4th variable. I think the physics applications or science applications are a little cooler. That being said, what is our one step? This. You don't like 2 variables? Then get rid of one. Choose 2 pair of equations to eliminate one of these variables, but the key is it must be the same variable. I'm not going to eliminate the x's on one and the y's on the other because I'll still have 3 variables. I need it to be the same variable. So let's pick a letter that we think might be easy to get rid of. We have 3 options here. I'm going to look at the x's, I'm going to look at the y's, and I'm going to look at the z's, and I want to decide which of these is easiest to get rid of. And there's not necessarily a wrong answer. We could do any of these 3. I see which one I would choose. What do you think? You're thinking the y's. I like that this is, well, none of them are the same number. This basically connects directly to the elimination method, right? So currently this is a 2 and a 3. I could make them both a 6. One of them's opposite. I could change the 2 to a 4, but I'd have to mess with that 3. I'm not loving the y's. It's not a bad choice. We could change this to a 6, this to a -6, this to a 4, and so you could do the y's. What might be a better letter this time? Everyone's so terrified of the z's because they're our new variable. I could make this a -3. I could make it a +4. I think the x's might be a little more convenient this time because this is a -3 and this is a 1, right? So I could take, let's say, these 2, and I could change that 1 to a 3, and that would cancel with the -3, right? and I could take that 1 and make it a negative 2 to cancel with the positive 2. I'm going to choose the x's this time. Does that mean I couldn't do it with the y's? No, you could. Does that mean I couldn't do it with the z's? No, I could do it, right? But I think the x's are easiest this time. So I'm going to choose, and I like to number these equations, my first equation, my second equation, and my third equation. Okay? So I'm going to choose equations 2 and 3, and I need to change one of them so that we can get rid of, we said, the x's. Okay? So what am I going to do with equation 3 so that the x's will cancel out? Multiply that sucker by 3. And that's going to distribute. Everything on there is going to get multiplied by 3. So 3 times x, 3 times negative 4, 3 times 3. Oop, that's a z. Apparently I'm scared of new letters too. And 3 times 9. And now the second one, the x's are going to eliminate. So we're good there, right? Just bring that one down. I don't know why that's kind of stuck in the middle of the screen, but we'll just have to deal with it. Sorry. Did that do what we wanted it to? Will that eliminate the x's like we wanted it to? Okay. So there go the x's. I'm left with, what is negative 12y plus 2y? What is 9z minus 4z? And negative 27 plus 2. Box that in. I'm going to call that equation 4. That is one of my new equations. We just made a new equation with only 2 variables. I feel much more comfortable with that 2 variables. That we've already done. That we've already done on the quiz. Okay? The problem is I need to choose another pair. A pair means 2 pair of equations, right? So, and I need to eliminate the same variable. I need to eliminate the x again. Okay? I just chose 2 and 3. I cannot choose 3 and 2. That's the same 2. Okay? I have to use equation 1. I can use it with 2 or I can use it with 3. And it doesn't really matter. You need to make the choice. I would like 3 because I think then I only have to change its bottom one to a negative 2. I might like 2 because they're already opposite, and I could just make them both a 6. But then I'd have to change both of them. So it's a choice, right? But if we choose 1 and 3, then I just need to take that bottom equation and multiply it by, how do I make it a negative 2? Multiply it by a negative 2. Everything times a negative 2 there. What's up? I don't have to multiply the equation. No, we're going to use that in a minute. That'll be on step 2. So I'm going to bring this one down. X times negative 2 is negative. X times negative 4, or Y times, yeah, I don't know what I'm saying. Negative 2 times 3. Negative 2 times negative 9. And the other equation we didn't have to change because we want the x's to eliminate. Do not restart my computer. Okay. So the other one we don't have to do anything to. Oh my goodness gracious, I hate Apple. Go away. Go away. Go away. Okay. So I can just bring that equation down. All right. Are we okay so far? This is the new step. Did it do what we wanted it to? Are the x's going to go away? And I'm left with what? What's 8 plus 3? Minus 6 and 1. 7z, right? And 8 and 5 is that 23. Box that in. That's equation 5. That is all step 1. But I need you to see that this is actually a really big deal. Let me get rid of the second equation so we... This is not helping. I need more space. All right, cut that away. Okay. We are now ready for step 2. Step 2, see, we have basically turned this 8.6 question into an 8.5 question. You just did a question like this on the quiz with 2 variables. You turned it back into something you already know how to do. This is the only scary step. We're done. Now what do? We're going to use our two new equations to cancel out their variable and solve. Basically, we already know how to do this. We're just now using all the skills we just did on the quiz, whether it's substitution, elimination, whatever it is, to eliminate another variable. Neither of these look great. I'm either going to try to get rid of these y's or these z's. So the y's or the z's. I'm going to go ahead and say, since neither one is better, and since you're all terrified of z's, why don't we get rid of the z's this time? Does that make sense? Currently, I got a positive 5 and a negative 7. They will not eliminate right now. This showed up on the quiz, and some people go, I don't know what to do with this. You need to do your homework before class. Okay? But if I look at this, how can I make a positive 5 and a negative 7 cancel if they were only the same number? What can 7 and 5 both become? So I'm going to take this top equation, and I'm going to multiply it times a 7, and I'm going to take the bottom equation, and I'm going to multiply it times 5. So the top one becomes, the numbers are going to get a little scary here, stick with me, negative 70y, 35z equals, what is 7 quarters? Is that 175? On the bottom, all that times 5 is 55y, 35e, and is that 115? This is step 2. What's going to happen with the z's? They're going to... What's going to happen with the y's? What is negative 70 plus 55? And I believe that is that negative 60? And here we hope and pray that at least I'm not throwing at fractions at you yet. Does 15 go into 60? Oh, yeah, thank Jesus and all that, or whoever you worship and all that. But what? Y is equal to? There you go. It's very refreshing. We finally got an answer. We're back to what we've done before. This isn't too bad. Are we done? No, we got 3 freaking variables to solve for, x, y, and z. We have found one. You've done over half the work at this point, but you only have one of the answers. Please don't stop at this point. Okay? Step 3 is not new. You've done this before. In fact, this is what we did in the previous section. Once we found an answer, we took that number and we plug it in. Where? I can go all the way back to the original, but I don't want to mess with 3 variables yet. So what I'm going to do is I'm going to plug our answer into one of the new equations. Why one of the new equations? We went through a lot of work to make 2 variables. So if I plug it into one of the new equations, I can solve for the 1 variable that's left. You with me? So step 3. Choose one of the new equations. We had 4 or 5. I'm going to plug in a y and solve for z. Which of those is easier to solve for z? I hope you're saying equation 4 has a positive z, doesn't it? At least. So let's check that out. Negative 10 times y plus 5z equals negative 25. Think we can solve that? Negative 40 plus 5z equals negative 25. If I add, 5z is equal to 15. If I divide, z is equal to what? We're almost done. Do you see what I said? Once you got that first answer, things start moving fast. You've done all that hard, terrifying first step, and then all of a sudden it's like, wow, I've done this before. I got my first answer. Man, the second answer came quick. Guess what? We still need one more answer, right? I got a y, I got a z. I'm missing the x's. Where are the x's? All the way back up at the top original equation. I have to take both of these now, and I'm going to substitute both of our answers into which equation? One of the original. And why am I going back to 1? Because I need an x. And those existed back at the original equations. So I'm going to go back up real quick to the original equations. They're probably easier to see on your paper, but I'm looking to solve for an x. Which of these equations has an easiest x to solve for? That's what you would say. The third one has that x all by itself, right? So I'm going to take that equation, see if I can use my technology to actually steal it. That's awesome. I don't care what you say. That's awesome. I'm going to put that here. This is now step 4. X minus 4 times, what's y? Plus 3 times, what's z? Equals 9. X minus 16 plus 9 equals negative 9. X minus 7 equals negative 9. X equals what? Negative 2. On our previous sections, I believe I only had 4 steps, right? 4th step, we were done. This one I said we were going to add 1 step. So instead of 4 steps, we're going to have, there you go. See, we can add 1 to 4. We're good. But here's the thing, right? This last step is really a formality. Because this is not our answer. This mess is not my answer. What is your answer? Your answer is a point. But instead of x comma y, it's x comma y comma z. And so what is our answer? What's x? What's the y? And what's the z? You don't need to understand graphing 3D at this time. That's not what the purpose of this is. It's just introducing the algebraic functions here, okay? But what does this mean? It's really not that terrifying. If you think about it, look. Do you know what an x value of negative 2 means? Go 2 to the x, though, left and right. So 2 to the left. 4. And that's where we'd stop before, right? What does a plus 3 on the z mean? Come off your paper 3 steps. We add a 3rd dimension. That's all that means. If it was positive, it comes up off your paper. If it's negative, it goes down below. I think stuff like this is interesting. You don't need to know that. I'm not going to make you graph 3D stuff. But I appreciate it. Like, what do we have, like a year or 2 ago? We had the Disney Diamond Days, and they had all these lasers going around. At the very end, they had the lasers all come together and meet at a point. You don't think that was 3 linear equations in 3-dimensional space? And there's math behind that, meeting at a point. Man, I think stuff like that's awesome. And I know that math ruins your happiness, but I see the math in that. Okay? All right. Here's the good news. Before I take that question, here's the good news. This is the hardest version of this question you will see. And I get that this is terrifying. We just did 1. We're going to do more. Okay? But all we did was add 1 step. And did you see how when I told you, I said what? Get really strong through 8.5, because then 8.6 adds 1 step. Some of you came in today and you're not strong with these solving methods from 8.5. Then this section sucks. You need to get strong through 8.5. You need to know how to solve 2 variable systems. Because then 3 variable, I add 1 terrifying step, but that's it. Alright, so we'll do this real quick and then I'll close this. Okay? Example 2. A little easier. But rinse and redo. Yeah. Oh yeah, but here's the cool thing about these. You'll notice each question takes about a page. For the craziest hard ones, okay? I look at these questions and I think of them like puzzles. And I like puzzles. If you don't like puzzles, then don't do this analogy. But how do I handle a puzzle, right? I take all the time and I organize and I separate the colors. And you pull out all the edges and you start by doing all the outside first. And that's tedious. Go through like 5,000 pieces and find the 100 that go on the outside. That's tedious. But once you get the outside and once you have it organized by color, then it just starts coming together. And as you do more of the puzzle, then it just like and at the end, it's so rewarding to get like that last piece in and see this puzzle. This to me is like a puzzle. It's really tedious at first, organizing all the pieces, kind of doing the border, but once you start putting it together, it goes quick, right? So look at this. Our first step, actually to get this one, it's actually partially already done for us. We want to choose two equations, two pair of equations to eliminate the same variable. What variable do you want to get rid of this time? X, Y, or Z? Pick one. X, Y, or Z? I heard Y. If I'm going to do Y, then I'm going to box this sucker in. Why? It's already missing one. So that is actually part of step 1 has already been done. I'm going to treat this like it's one of my new equations. I want to get rid of Y. Equation 3 already did that. So that's why I said that first one is kind of the hardest version of the questions that you're going to see. This one looks harder, but it isn't. They've already done part of step 1. The third equation is missing a Y, isn't it? Could I choose the other two and get rid of a Y? Well, one of them is a 4 and one of them is a -5. So I'll need to change them. Make them both a 20. So that means the top one's going to get multiplied by, the bottom one's going to get multiplied by 4. And so the top one's going to become everything times 5, 25x, 20y, apparently a lot of 115s today. This one's going to become negative 20y minus 8z equals just 12. And what eliminates? Just like we wanted. But you're left with now an equation with only x's and z's. But equation 1 or 3 was just like that. It only had x's and z's. So we've done what we needed to do. This was the terrifying step. This was the one new terrifying step. We now have two equations, because this just becomes what? 25x minus 8z equals 127. We now have two equations with two variables. You have in one step changed an 8.6 question back into an 8.5 question. Don't be scared of that. Is that okay? So now I need to take these two equations and eliminate another variable. That's step 2. We're using use the two new equations to eliminate and solve another. Okay? So pick another variable. I would say pick the smaller of the numbers, because none of this is going to be pretty at this point. Z, I think, is our best choice here. So the Z, I got a 9 and an 8. They're at least both opposite. I could make them both what? So that's going to be, this was all step 1. This will be step 2. I'm going to take that equation up there and I'm going to multiply it times 8. And this one times 9. That one times 8. I'm going to go through a little fast. 64x times 8 is that 72. Z. Do not forget to multiply the -2 times 8. -16. This one times 9, 9 quarters is 175. Minus 72z equals, oh Lord, what is 9 times 127? What's 900 plus 180 plus 63? I want to say 1143, but what is, I know, what's 9 times 127? Look at me asking you to use a calculator in your math class. What a jerk. I know. Hey, I could do math still. Did this do what we wanted it to? We wanted to eliminate another variable, did we? Can we now solve? Right? And can we now pray that this number goes into whatever this mess is and is not a fraction, right? See, math brings you closer to God. You didn't know that, but there you go. Okay? What is that? Negative 100, or is that 111? I don't think this is going in, but we'll see. Is equal to 1027? No, 1127? I don't know if this is going in. Maybe we made a mistake. What's up?
How did you get 175?
Where's the 175?
Because I got 225 and I multiplied 9 times. It's 225. It's 225.
Well, that might change the entire question.
Yeah. It's not 175.
Well, then, yeah, keep me honest. So you're telling me this right here is supposed to be a 225? That's why I was asking you guys if I made a mistake anywhere.
Well, I just checked.
Oh, okay. So, and 225? And 64 is what? Oh, get over it. We're going to make mistakes. She said this number right here was 25 times 9. And I put 175. It should be 225. So these combine to give us 161. I don't know if 161 is going to go in there. But let's see. So 1127 divided by 161. Oh, that's fine. No, it does. Huh. Isn't that beautiful?
So erase everything?
No. Just erase one line.
1127 on it?
And x is 7. That's a much nicer number. This was supposed to be a 225. You okay with that? I highlighted my mistake. I'm not that proud. Okay? There's my mistake. That makes 161. When I divide by 161, it goes in there evenly. Okay? Here's another thing, and this is what's scaring me a little bit right now. Do you think you're going to make some mistakes in this? Oh my gosh. And here's the problem. Somebody's going to get to this point, and they're going to maybe divide by 111, and they're going to just stop. And they're going to basically earn like maybe a quarter point or a half point out of 2 total, and that sucks. But could you take that number and just go, I can't find my mistake. I'm going to keep plugging it in and find the other 2 answers. And if you do that, I will take off a quarter point because you made one small mistake and everything else you did correctly. So persevere on these. Did you hear what I said? Persevere on these. You're going to make some mistakes. I'm going to make some mistakes. I'm going to take 2 puzzle pieces and force them together and then near the end go, oh crap, this puzzle looks wrong. Okay? That happens. Thank you for catching my mistake, by the way. All right. So x is 7 makes this way easier because now I'm just going to do what's negative 8 times 7. What is it? Just 56 negative? So what's negative 56 plus 9z equal to 2? If I add the 56, 9z equals 54. If I divide by 9, z equals 6. The numbers would have been messier the other way, but if you do that on the test, and then all your answers are going to be all crazy at the end, I will go through your work and I'll go, oh, you put 175 instead of 225. A quarter point off. That's a small mistake. Persevere through these. Okay? All right. So now we got an x, we got a z. Step 4 says, I need a y. Where do I get a y? Go back to the original equations, and I need an equation with a y. Go back to the original equations. Right here. Which one has a y that's easy to solve for? 5x, 4y, 23. 5x. All right. Was this last number supposed to be a 23? All right. I'll answer your question. Let me just make sure I'm typing this equation right. Yes, I am. All right. Yes, I'm doing some of the Math 55 stuff quickly. Yes, it's 56. When we add the 56 over, it's 54. Okay? No, it's okay. But now we're all getting confident, calling me out like I don't know what I'm doing. That's okay. It's okay. I like the confidence. I wish somebody had done that and saved me a bunch of time there. What is 5 times 7? The top one. plus 4y equals 23. Now I'm going to do my quick math here because we're not in math 55 anymore. We know to subtract the 35 over, right? And get that 4y equals negative 12. And then we know to divide and get that y equals negative. That's step 4. What's step 5? What is our answer as a point? 7, negative 3, and 6. 7 to the right, 3 down, and 6 up off your paper. That's what that would look like in a three-dimensional graph. You don't have to do that, but I think things like that are interesting. Good job, guys. That was a tough one. Okay? Let's keep going. See why I don't have 3 sections of notes today? We are gonna take a break after this section too, because I know some of you are broken already. So. Example 3. Step 1. You don't like 3 variables. Get rid of one. Which one? Man, one of those z's is just ready to cancel. That's right there. Those are just ripe to go away, right? So I'm liking, we're going to get rid of the z. It sounds like I'm saying get rid of disease, which is also cool. But so I want to choose 2 pair. I'm going to choose equations 1 and 2 because they're all ready to cancel out, right? 3x minus 2y, yeah, plus z equals 8. 4x minus y minus z equals negative 2. Goodbye, z. What are we left with? 7x. Is that 6? That's one of our new equations. I just chose equations 1 and 2 to do that. We have to use equation what? We have to use equation 3 at this point. We haven't touched it yet. So I'm going to match equation 3 with equation. I like that because even though the z's are not the same number, right, this one is positive and this one's negative. Agreed? So I'm going to take that top equation and I'm going to multiply it times. How am I going to get a positive 1z and a negative 2z to cancel? Top one times 2. That's going to make that 6x minus 4y plus 2z is equal to 8 times 2 is 16. Negative 6x plus 4y minus 2z is equal to 3. Well, this is kind of cool. Did this... Oops. Oh, my freaking goodness. Just settle down. Gamate. All right. Did the z's cancel? Oh my goodness. But what else happened this time? What's left on the left side? 19. Wait a second. That's not infinite solutions, is it? What does that mean? Basically, these 2 lines are parallel. They will never cross. They don't have a point in common. I may end up with a solution with maybe one of them, but they'll never, all 3 lines will never have a point in. So this is not something to be sad about. This just saved us a lot of work. I'm done. The minute I get all the variables to go away and I'm left with 2 things that are different, this has no basically parallel lines. Basically, these will never all 3 cross at the same point. Make sense? That's not too bad, comparatively. All right, I'll wait a second. What? Yes. Eventually, we would end up with no solution somewhere. You may end up, if you did the third and the second, you might have got one between those 2, but then when you tried your 2 new equations, they would have eliminated. At some point, this is going to happen, yes. All right, I'm going to scoot this down. You don't get what part? after I did this. Remember, and this is the first step. The first step is to do what? Look. I want to eliminate the same variable, right? Come on, just do what you're supposed to do. There we go. So I chose these because Namus was ready to cancel out. You with me? So no problem bringing that over and canceling them out. You feel good about that? Okay? Save the conversation, please. On this one, I had to choose equation 3. We hadn't messed with it yet. You have to factor that one in. So I had to match this with one of the other two to eliminate the same variable. So how would I get rid of that 2z? Well, man, I could make that positive 1 into a positive 2 and then they'd eliminate. Yes, but you have to eliminate the same variable. So what was cool about this one was that when I did change it, everything disappeared. That shouldn't freak you out. We saw that before in the previous sections. That just means these two lines, they don't cross. And I'm looking for a point in common. These won't have one because of the two lines that never cross. Does that make sense? Thank you. Good question. All right. Next one. Oh, Lordy, what makes this one look terrifying?
Oh my god, vortex.
All right. We'll get over it. We'll get there in a second. Okay? Oh, man. All these little puddles appear around the classroom. You'll be okay. All right. I know, it's terrifying. We'll deal with the fraction 1 in a second. Let's just deal with maybe equation 1 and 3. I don't know. Let's just take equation 1 and 3 and just ask, is there a variable there we could eliminate? Pick one, x's or y's. I wouldn't do the z's as much, but you could. I would do the x's or the y's. Pick one. I heard x. Okay. Currently that's a 3, this is a 6. For them to eliminate, they have to be the same number, but opposite, right? So I'm going to change that 3 into a negative. Yeah, I'm going to multiply it by a negative 2, and that's going to change it to a negative 6. Does that make sense? So this is negative 6x plus 8y minus 2z is equal to, is that negative 24? Now this is another cool thing, because what happens to the x's? Just like we wanted, the x's will what? Goodbye. What happens to the y's? Poof, right? Them sound effects are fun. And then we're just left with what? Z equals. Then that was cool. That doesn't always happen, but that's nice when it does, right? We just got Z. I still got to use that middle equation, but we just got a Z. Is that fair enough? So what are we going to do with that middle equation that we've been avoiding with all those fractions? Times it all by what? What are the denominators that we want to clear out? They're all 4. So what if I multiply that entire thing times? Did I do that? What would it become? What's 3/4 times 4? What is negative y times 4? What is 1/4 times 4? Equals 3 times 4 is 12. That's interesting. I need to choose an equation to eliminate with that equation, that equation too, right? If I wanted the top one to eliminate, and we try to get rid of the x's, so I'm going to try to get rid of the x's again. Currently it's a 3 and a 3. What if I took that top equation and multiplied it by negative? Would that make that 3 negative 3?
Yeah.
What else happens though? So the x's went away like we wanted, but then the y's went away, the z's went away, 12 went away. So what am I left with this time? What does that mean? That's where there's many or infinite solutions. This would be many solutions. You could put infinite solutions. I'd be fine with that. Or, for fun and giggles, if you wanted to, this is like what the homework will do, is they'll say any point x comma y comma z that meets basically the equations. I'm not as worried about that. Just put infinite or many solutions, we're good. Okay? I don't want to lie to you. I think there's one more example. Let me double check. One more example. Okay, you ready? What? Example 5. At a local bakery, a loaf of honey wheat bread costs $2.69. Sunflower bread is $2.89, and French bread is $3.39. On a recent day, twice as many loaves of sunflowers were sold as honey wheat. The number of loaves of French bread sold was 3 less than the number of sunflower. Total receipts for these days were $96.58. How many loaves of each type of bread were sold? Oh, freaking A, word question, right? I know. We have 3 variables we don't know. Remember I told you that the 3 variable has business applications? Here we go. What's the first thing we don't know? Of what? There's 3 different types. Honey wheat. We could call that?
Z.
We generally don't start with Z. X. Sunflower bread we could call. And French bread we could call. Now, I'm going to encourage you that though that makes complete sense at this point, later on there's a sentence that has to do with like how French relates to all the... It's easier sometimes just to call this one H, S, and F, because then it's going to help me keep track of which is which. Does that make sense so far? Okay? If you use X by Z, there's nothing wrong with that. Just going to make the next part a little harder. Okay? Here's what they say. We have a total, this $96.58 is a total cost. How do I get that total cost? Well, it's every individual cost. It's the cost of the honey wheat times the amount of the honey wheat plus the cost of the sunflower times the amount of sunflower, or times S, plus the cost of, what's the last bread? Cost of the French times how many do we sell? F. This is a total cost equation. It's each cost times each amount. Each cost times each amount. Does that make sense? We do this whenever we total up something at a store. We do what's the cost times how many did I buy, plus the cost times how many I buy, and it equals a total at the end, right? Fill in what we know. Do we know the cost of the honey wheat? Somebody say $2 and? There we go. Times. Do we know how much of the honey wheat we bought? No, we'll call that. Do we know the cost of the sunflower? So we'll put $2.89. Times, do we know how many sunflower? It's our S. Plus, do we know the cost of the French bread? Times F equals, what's the total? One other equation that you should be familiar with that we don't use in this example but might pop up in the homework is if they give us, instead of a total cost, if they give us a total amount, which they didn't this time, but if they give us a total amount, it would just be the X plus the Y plus the Z, or in this example would be H plus S. If they said, I sold 52 loaves of bread, then that would be those 3 variables add to 52. Does that make sense what I'm saying? Now, we didn't use it this time, but that is one that does pop up. Okay? All right. Our second now, here's where we get a little crazy. It's not that bad. Twice as many sunflowers are sold than the honey wheat. So, twice as many sunflower were sold as the honey wheat. The sunflower, S, was twice as many as the honey wheat. How would you do that? 2 Twice as many sunflowers were sold as the honey wheat. There were more sunflowers. How many? Twice the honey wheat. No, it's H. The number of French bread was 3 less than the number of sunflower. Okay, the number of French bread, what variable is that? So from this, F is equal to 3 less than the number of sunflower. That's what? 3 less than S. These are our 3 equations. Does that make sense? There are 2 ways of solving this, an easy way and a hard way. The hard way is I'll have some people that will try to use elimination. They'll try to line things up and eliminate a variable. This is set up for substitution. How do I know? I got S equals F equals, I got a variable by itself. Does that make sense? This is set up for elimination, or for substitution, sorry. I don't like that equation with all the decimals, so I'm going to multiply all that times, well, 2 times, so times 100. So 269H. I'll need your help on some of this math, because you've seen my math skills today. And now I'm going to start substituting. In place of S, I can put what? I heard 2H. I just substituted that from that second sentence. Is that okay? Plus 339 times, what's F? Substitute it. Now this did something really good for me, because I used to have 3 variables, and now I only have 2. I still don't like 2 variables. I only want 1, right? Is there anything else I could still substitute in there? What's S worth? So I can take that S right there. I'm going to start cleaning this up as we go. 269H plus 289 times 2. Somebody double check my math, but I got 578. Plus 339. Maybe. There we go. Times, in place of that S again, I'm going to put now I got 1 variable, all H's, right? The numbers are going to get big, but you got a calculator, that doesn't scare you. 269 plus 578, 7, 800, 847. Please double check my math. 339 times 2, 678, minus, oh, that one's fun, 339 times 3. Times negative 3, the 3 is the one I'm scared about. 990, 27, I got 1017. Now I'm still solving for H, which means I'm still combining like terms. 14, 15, what? Is it 1525? That doesn't seem right. Maybe. Five, carry the 1, 8, 2, carry the 1. I think it's right. We're 2 steps away. How do I get H? If I add 1017, we get 10,675, I believe. If I divide that by 1575, we say a little prayer, does it go in evenly? If not, I made a mistake somewhere that you all should have called me out. What does H equal?
Didn't you put 1525?
Yes, see? Good, keep me honest. 1525. It does go in, I believe, right? How many times? 7? So we're all done? No, what do I need to do still? But all the hard work is done. Look at those original equations up there. If H is 7, what's S? 2 times 7, S is 14. We just did the outline of the puzzle. That's a lot of hard work, I get it. But once you're done with that, once you've done all the hard work, it all starts falling together. S is 2 times that, 14. So what's F then? Is this right? Could you check it? See, because it should total to, what was it, $96.58, right? So if I bought, 7 loaves of H, 14 loaves of S, and 11 loaves of F, is $2.69. Where's my calculator? $2.69 times, how many H's did we have? 7. Plus, what was the second cost? $2 and $2.89 times, how many loaves of the second bread did we get? Was it 14? Plus, what was the last cost? $3.39 times 11. This should equal what total? $6.58. I think that's pretty cool. Okay? I get that this is a lot of hard work, but once you do the hard work, it cleans up really nice. Does that make sense? Persevere through this. This is not that hard of a section. It adds one step. This is really the only new stuff. All the other systems of equations should be reviewed. Okay?